All right. So it's 4 p.m. and let me just switch to the slide deck. All right, everyone. So this talk is the diagnosing issues with Windows Phone 8.1 JavaScript apps using Visual Studio. Technically, it should say Visual Studio Update 2 release candidate, but the title was already ridiculously too long. So hopefully everyone in this room is here to learn about how you can debug, diagnose, profile applications built using JavaScript on your phone, on the new Phone 8.1 platform. So hopefully that's the right place. So my name is Andy Sterland. I work as a program manager on what we call the Web Client Tools team. So I work on the tools that, if any of you are web developers, in fact, is anyone a web developer here? You build apps for Internet Explorer and stuff like that. So I work on the F12 tools. So some of you might have seen those. They're updated in i11, like the DOM Explorer, the console, the profiling tools, and things like that. We also have a great set of updates for those this release, but that's a different talk. And I also work on those same tools in Visual Studio. So we consider like HTML, CSS, and JavaScript like a universal platform to itself. Like obviously it runs both now on the phone with the IE11 and the store apps, as well of course on your desktop, both in the modern browser and the desktop browser, and then lastly the Windows Store apps, HTML and JavaScript. And so I work on the tools that target all of those things. We try to build the same tools, because after all, you're trying to solve a JavaScript problem, you're trying to solve a perf problem, you're trying to solve a styling issue or something like that. So we have the same tools in all these places. So it's almost like we have a universal tool set. Oh, wait. So set some expectations for this talk. So this talk, I'm mainly going to give you an introduction into each of the tools we have at your disposal, you'll have at your disposal for building these HTML apps. I'm not going to spend much time today talking about the build and project side of things or language service features. I'm really talking about everything that happens when you press F5, or in the case of profiling, you press Alt F2 and then another button. So the idea here is you've got your app up and running. I'm going to show you the tools and how you use some tips and stuff on how you can debug and inspect and build faster applications that work well for your customers. We're not going to have enough time to go into every tool in a great deal of depth, because obviously there's a huge amounts of diversity in the tools we have, and we're not going to spend any time, for example, talking about parallel call stacks or anything like that, which is a whole fascinating topic. The first thing, before I get to demos, which is going to be what I'm mostly talking about today, is that the most exciting thing is that with the support for store apps on phone, Visual Studio now has all the same tools you're used to for targeting against store apps on the Windows platform or your desktop IE, like the tools like the debugger and profiling against both IE on the phone, store apps on the phone, both the JavaScript store apps, and as well as if you have a managed or native control that embeds a web view. Like, does anyone build applications that just embed web browsers for various reasons? You can also now debug those, which is really handy if you've ever had that sort of app, which is pretty common. This talk, though, will mostly focus on just the store apps for phone store apps. I'll also do some demos at the end that look at the other two scenarios. This talk is kind of going to assume you're familiar with HTML and JavaScript and the app model. Has anyone built a Windows web app for, let's get this right, a Windows Store 8 app for JavaScript and HTML before? So you're kind of familiar with like the life cycle, familiar with WinRT and stuff like that? Okay, that's interesting. On the plus side, I'm not actually going to talk about any of that today. And my application that I'm going to demo is all about going to be taking an existing website and packaging it up and make it work inside a store app, which is going to be fun. So the other thing, the assumption, I am just talking about diagnostic tools. So if you write code that's perfect, or if you copy code that's perfect, then obviously you're not going to need any of these tools. Luckily for me, many developers, including myself, have great need for these tools, so it keeps me in a job, which I always like to be in. So I'm going to go ahead and flip to my demo machine. Magic switch. Okay, so we're mostly in Visual Studio. This is the Visual Studio. You can download the 2013 Update 2 in the background here. So what I'm going to be doing throughout this demo is I've got this website that I'm going to convert and have run as a store app. So it's my ingenious website where you basically have to guess the Netflix rating. So you've seen Netflix, they have a data API, we're fetching data, and I'm going to guess like Barney Singing Dance is going to be 5 stars. Yeah, how did I know that was a 5-star game? So the idea is it's just a game, it doesn't really matter what it is. And my idea here is that I'm going to try to get this same code to work inside a phone store app. So I can get rich, so I can sell it on the store. Because clearly the advertising stream for my website isn't working particularly well for me. I'm not that rich, which is probably a lot to do with the fact that I don't have any ads on the site. But anyway, so before this talk, I went ahead and I created a project. So this is just using a basic file new project for Windows Phone using JavaScript. It's not using the universal store model, and it's because for this talk it wasn't really important. I've gone ahead, I've literally just copied the code I had from my website into this project. creating folders, copying files, things like that, but I've not changed the code yet. I've also gone ahead and changed some things in the Apex manifest. So the manifest essentially describes the application to the operating system, and in this case, I've done things like customize the background color for the splash screen. I've done things like add a couple of icons. All of that doesn't really matter for this talk. It just makes it look a little bit prettier. So after copying these files, the first thing I'm going to do is just going to run the application. And the first thing you'll notice when you come to running an application, which I just glided over there, was that you have a bunch of options. You have a bunch of emulators. So these really, the emulators have the same capabilities in terms of like you could have the same touch sensors, the same GPS type stuff, but they have different screen sizes in particular. So you can see here, obviously there's different physical dimensions as well as resolutions, such as YXGA and YVGA, and of course 1080p. The other thing that's different is one of these has only 512 meg of RAM. So that's an important consideration later on to think about when you're building applications that you want to work on devices of low memory. Anyway, for this demos, I'm just going to be using the emulator. All these tools I'm going to show support tethered devices. So if I took this device, connected it via USB cable to the laptop, it would all work brilliantly. The downside is demoing it's really hard because you'll have to look at the screen over wolf vision. So instead, I'm just going to use the emulator. But when you go home, and use these tools, you'd work fine over USB tethering. So again, just going to launch it. So the first thing you'll notice is that it's very similar to what we have. If you've seen the phone emulator in the past, you have the settings down the side, for controlling the touch inputs for when you want to do pinch and pat, and as well as rotation. So the first thing, so the app doesn't look unreasonable. You'll note that it works. Like, it doesn't look great by any stretch of the imagination, but it kind of works. But there's a few problems with it, like straight off the bat, that I would like to change. So you can see that, in general, when I'm taking something from a larger website that it's used to display in different form factors, for a smaller one, I'm going to have to start tweaking things. And so that's where our tools come in. You can see that we've launched the DOM Explorer. So here, who here has used the DOM Explorer before? Like, has anyone else used this tool on? OK, a few people have. So this tool, its primary purpose is to help you inspect the magic box that is the browser. You obviously feed in HTML, CSS, and out you get some sort of rendered image. The problem, of course, is that black box can be very difficult to understand and trace. Like, if you've ever had to think through CSS and HTML being applied, the cascade, it's super confusing. I sure as hell can't do it. So that's why we build these tools. And we have things like the select element button. So I can go ahead and select an element on the tool. So just like you'd expect if you're debugging a normal website across the emulator, and on your phone, if you're to do this, you just use your thumb, which is not going to be as accurate as a click, but it'll work. So you can select the element. In this case, I'm looking at the movie thing, and I can see all the styles that have been traced across it. I also can do very obvious things, like say this battle, the awesome text here is just too small. One of the things I can do is I can use these tools to tweak. So it's not just about inspection. These tools are about helping you apply changes dynamically so you can see what happens. So it's very familiar if you're a web developer. You should all seen similar stuff like this. The first feature that's new and showing is this little yellow bar. I don't know if you can see this. Let me zoom in. But this little yellow bar here, it tells you these properties have changed. So what tends to happen is you're working on a site, you tweak lots of properties. You change values, you move them around, and it can be very hard to keep track of that. Like maybe there are permanent changes, but sometimes perhaps you're experimenting. So here we highlight them, and you also, if you do things like, say, I remove this color property, and let me just remove it, delete item, you can see we colored it red. And similarly, if I add one, it's going to color it green. So let's just, for the sake of argument, add a property for text decoration. Text decoration, and make it underline. And again, just like the tools you get for Visual Studio targeting Windows Store apps, the 8.1 ones, you get the same features. You get IntelliSense on CSS and stuff like that. And so you can see it's changed. The nice thing here is when I go off this element to other elements, and I come back to it, it's still highlighted. It tells me what has changed. The other really handy feature that you'll find useful is you can use the revert button. So if you've ever changed something and you've forgotten what the original value was, you can just use right-click and revert, which is much better than, like, if you have an undo stack, you can obviously go Control-Z, but sometimes you have undeleted ones, so it's not very handy. The last feature specific for this that's new in this update is the changes. So here you can see a tab that lists all your current changes. So it tells you, hey, these are all the things you've currently tweaked in this current session. Anyway, so to get to the task at hand, for what I want to do right now is I want to change this. So rather than having this left aligned, as you can see today, I want to have it like more center aligned. Like, let's just start there for something simple to do. So if I was to look at this element, just like you would normally, I would note that like it's floated left. So that's part of the reason it's aligned to the left. Obviously, the idea of float left, you're removed from the layout, and your boxes are lined up. If there's not enough space, you wrap under and you wrap under, which is kind of what I wanted on the website. And it actually kind of looks nice when I rotate. Like when I rotate my application, it's 3. That looks pretty reasonable. but I want something different in the smaller form factor. So the first thing I'm going to look at is using some media queries. So hopefully you're all familiar with media queries, but the basic idea here is that you take, you take what you had and branch it. So one of the things you have to do for sometimes in layout is it's wonderful to have like this UI that works perfectly across every kind of resolution, from a phone to a huge TV. But in reality, you often have to tweak your layout, and not just tweak it by moving the sizes, but dynamically and radically adjust the layout form. So in this case, what I'm doing is I'm saying, when the media is all, so all is basically, that's the media type. So you commonly see things like screen and print. So if you ever go to print a boarding pass and it looks different from the page you printed it from, they probably use a media rule just to inject adverts. Normally you'd use them to remove them, but I assume boarding passes like to print adverts. But obviously you do more useful things like remove images and stuff. And then the second thing is a condition. So this is saying like, hey, when should I apply this rule? In this case, it's when the width is in this case, it's less than 400 pixels. So it's not the case, it's using CSS paradigms like max width and min width rather than greater than or less than. And so in this case, what it's going to do is going to make it line center and display inline block. So what that should do is that will actually just center my elements rather nicely for me. And what you can see, again, if you use the DOM Explorer, so obviously that thing's applied and that's the correct way to do it, or at least one way of doing it. And you can see in the DOM Explorer, we show media rules and things like that. So you can see when a rule comes from a media rule, because one of the challenges you'll face is, this is a fairly simple example with just one condition, but you'll probably build up a whole bunch of media rules to apply over time, and it can be somewhat confusing to follow exactly which ones. So we show those in the DOM Explorer, just like you'd expect. So the next thing I want to work on actually is another common problem for building UI that targets the phone, and that relates to the size. Oh, and if you ever get fed up with this underline, you can turn it off that way. But one of the things is, you move from one form factor to the other is that sometimes hit targets become too small. So you've all seen it where websites, you have to zoom in and stuff. Whereas like this is an app, so we're not expecting customers to zoom in on parts of our app. Instead, we want our app to look like the right size to begin with. Obviously, if this was IE, it would look slightly different because IE would scale the text and stuff, but you're running inside an application. And so you're not really, you can obviously create zooming, but you probably want your user to have a great experience without them having to zoom in. So what we're going to do is we're going to find out a way of making these stars slightly bigger. So if I select them, again, I can discover the size and things like that from the Layout tab, which I'm sure you're mostly familiar with. In this case, it's 16 pixels. The height is actually set on the parent. It's 80, the width, sorry. So what I want to do now is I want to try to figure out how to make these stars bigger. So let's just stop debugging for a second. And then, OK, so this one, what we're going to do is we're going to try to calculate the size. In fact, I forgot a very simple step. Dynamically. So I'm using a third-party library called RateIt that's just I can pass in a pixel width and height, and it'll use that to calculate the size. I can't pass in a relative value, though in some cases, like EMs wouldn't be applicable, but I can't pass in something relative. So instead, I'm going to have to try to figure out what the resolution is. So one way in which I can calculate the zoom level, essentially, which is kind of what's going on under the hood, is I can look at the device X DPI and the logical DPI. So if you've ever made a website today and you've had a pane where people have zoomed in your website, so say you're an IE and someone has done like control, like mouse wheel, and it looks like they said it to 110 or something like that, and it looks really awkward. That's because obviously your UI is not accounting for that. Pro tip, by the way, press Control-0 to get back to 100%. Like I do it all the time, accidentally mouse wheel. So if you want to get 100%, Control-0. And so what we're going to do is we're going to try to find out what the zoom level is for this device. Because ultimately, you don't want to create UI that only works in one particular or two particular variants. Like clearly here, I could change the value of 16 to 32, which would work. Like that would work great in the emulator, but perhaps it wouldn't always work. So instead, I'm going to do something pretty basic and calculate the thing dynamically. But do that in my default JS file. And close this, because we don't need to see this right now. And then I'm going to look for the RateIt control. And so I've already got the code in. Who would have known? Oh, no, it's the handle answer code. Sorry, it's right at the bottom. So I'm going to find the piece of code where I initially show this thing. And then I'm just going to do this small calculation to figure out the zoom level that's currently applied. And then what I'm going to do is apply that and send it to the RateIt control that I'm using. And this is where I remember where it went. There's a separate one, handle answer. OK, here we go. So the first thing I'm going to do, just throw in the calculation, which is pretty straightforward. There's nothing scientific here. It's just taking the base size and then taking the zoom level and multiplying it. That's not rocket science tool. This is my the API, the library I'm using called RateIt. So I'm going to pass in these properties to it. It takes the properties just as arguments, so that's pretty straightforward to copy and paste. And then just copy and paste again. So this is how I do all my coding. I like to drag from the toolbox and just copy. Sometimes I copy from Stack Overflow, but mostly just from the toolbox, which works much better than typing, I find. Anyway, so I'm going to set a breakpoint so you can see a couple of the debugger features now. So we're just going to set a breakpoint as you'd expect. F9, and then F5, and launch it. So of course, just like you have on Visual Studio debugging JavaScript for other application types, all the features like async call stacks and stuff are here. So has anyone seen like promises and XHR and stuff where you see where your object was wired up? That's all available here. But in this case, we're just going to do some pretty basic debugging to see through my math. So the nice thing, I don't know if anyone noticed that, but as I step, let's start again. Let's set the statement there. Typically, if you're using a library like jQuery or something like that, or another library, you end up stepping into it. Like you then on debug sites, and you end up stepping into other people's code all the time, and you're like, how the hell do I get here? So for some time, since 2013, Visual Studio supported just my code for JavaScript. Have any of you made much use of just my code for JavaScript? Probably not. It's an interesting thing to set up. So in this case, as I step, magically it's stepped over that file. Like I've not stepped into jQuery despite pressing step in. It also changes your exception behavior, like you won't break on exceptions that are thrown and caught inside jQuery if you have first chance exceptions on. But the problem, and one of the things you have to do as a developer that can really help you, is that as you step, and say you step into another library, like in this case, I'm about to step into my rated library that the other person wrote. So, oops, have I already changed it? And let me just redo that, sorry. So the handy tip that I was about to tell you, and apparently I've already made the change for, which is a bit of a mistake, is if you rename a file, I don't know if you can see this, but Visual Studio decides which files are library code based upon a couple of things. It has a built-in rule that says anything, if a URL matches star.min.js, it'll mark it as library code and won't step into it automatically. You can also customize this by adding a file to your project called name it mycode.json, and then you can very specifically add URLs and stuff. Right now, there isn't any UI to do this inside Visual Studio, so that's why it's probably one of the more missed features. But you can very easily, if you want to, you just rename a file and add .min.js, which frankly is a bit of a shortcut, but it's the easiest way to mark files as library code. So if I was to rename this file and remove that .min, which I should have done at the start of my demo, and then we turn off the zoom, because it's really going to be awkward, and then go back to my default HTML to change that, because obviously updated, and save and deploy. Now what will happen as I break, I will step into the file, which is obviously not the behavior I wanted. So to avoid that behavior, as I mentioned, you can just name your file .min, and that recognizes that particular file as just my code, which is going to be really helpful to avoid situations just like this one, where you're debugging through someone else's code. Like I said, you can also change it by adding a file called mycode.json, but we'll skip over to how you do that, because that file either has to sit in your project or it has to sit in the program files directory, which will require you to obviously have admins. Anyway, so let's just change that. In fact, we just want to debug that again. So now when I run my application, forgetting the whole point of it, hopefully what we'll see is that the stars are twice as big. Like all I've done is calculated the size of them, doubled them up, and now when I run, with any luck, if I just skip the breakpoint, unfortunately, that's not what happened. The first thing that happened, as you can see, is that I've kind of got like 4 times as many. Like what's happened, of course, is that we've got twice as many width, twice as much height. So if I look in that in the DOM Explorer and inspect the element and figure out how it's laid out. So I'm trying to figure out like how is it this image drawn. Like in this case, you can see it's a background, and it's just been set to repeat. So a nice thing you can do if you know a specific property you're looking for is you can go to the computed styles and filter. So if you ever wanted to, like, say you're looking for font or something like that, and you don't want to look through the entire list, then the easiest way to do it is just type in background here, and obviously it will reduce the list. This view is also changed for this update. What it does now is we used to have trace and computed as 2 separate tabs, but we've combined those into 1 tab, and we've enabled editing. Like in the past, if you were in this view, you couldn't edit, but now you can, which is pretty handy for a bunch of reasons. And also, we've added the computed value. So if you look at a value like font, or anything that was set by a relative size, you see the calculated value. So it's just showing you the computed style. So we combined the styles in trace view into one and made filter work. If you're really excitable, you can also show everything. So if you're interested in what the default properties are, you can turn on this little button here, and it shows absolutely all the default styles. So these are ones that I had determined it was essentially the user agent styles. Not always the most useful thing, but sometimes it can be handy if you're wondering why things are Times New Roman, which is the default font sometimes. Anyway, so the next step here is try to figure out this problem. So I've got a couple of choices. I could go away, I could redo my assets in a particular resolution, and or do SVG or do something else. But I want to take advantage of a feature of the platform. One of the nice things about being a store app and not being just a regular website is there's a couple of features in the platform that enable things that aren't possible on the web today. Like a classic problem for a website is to say you have an image and you want to have different resolutions based upon the size or the DPI, like a retina display or whatever. That's very hard to do. There isn't a picture element and there isn't really an element that does that today. But one thing in the platform that's pretty nice is that they have a concept of how should we say, resource redirection. It's called MRT. So this image here, this star.gif, that's the image that's being loaded. But what I can do is I can suggest have an alternate image. So if you can see here, this says scale -200. So what's going to do is that tells Windows that when the scale is set to 200, as in 200% or 2, load this image instead. So when I request star.gif, so in my code, like it could be XHR, it could be CSS, wherever it is, I just type star.gif, and the network stack is going to resolve at 200, scale of 200, it to this image. So instantly, I can not only apply a more appropriate artwork, like I can have completely separate artwork. Like in this case, I've decided that rather than showing a star, I'm going to show 200, using my awesome Paint.net skills to draw that image, which is why it looks so terrible. So this time, when I start my application, what you should hopefully see is just 5 buttons, but just like you'd expect, which is all great. So this is like the classic sort of thing. This is one of the nice things about a store and the protocol we have for loading resources is you can have alternate ones. And it isn't just about scale. It also can be done on things like locale. So if you're familiar with like ENUS and other types of locales, you can have fallbacks. So in different countries or different locales, rather, you can have different resources. Things that aren't possible via a website. And this is one of the reasons that it's nice to move to the web store, store apps, is because you get this extra functionality. So the next thing I'm going to very briefly touch on, actually, is a feature called fast refresh in the console. So does everyone use the console tool? Have you used it much at all? No, just me. So a couple of people have used the console. So firstly, you'll notice there's a lot of these errors here. So if you've ever built a Windows Store app and you've used a library like jQuery, you'd have noticed these security alerts. And so what they're basically telling you is that the security model for these store applications doesn't allow or doesn't want people to inject script dynamically by inner HTML. So if you do inner HTML, .inner HTML equals some script tag with arbitrary content, it will deny it. The concern is that a lot of times you want users, these apps have more capabilities. Like I can have access to camera, I can have access to microphones and other things. And I don't want to take content from the web and just eval it. Like you don't want to essentially inject other people's content that might be entrusted. So in this case, this is jQuery doing some tests to actually try to figure out some tabled stuff, but it doesn't really matter. So we can just ignore those. There are workarounds. If this is a problem and you want to build an application that makes use of these features, your options are to put it into a web view. So if you're familiar, in HTML, there's a new tag we added, x-ms-webview, and that can then point to your internet content, essentially. It doesn't have access to your local, like the WinRT. It doesn't have access to your directory or camera or other things, but it does have the same security model as the web. So it's an interesting trade to make. And also, in this release of Visual Studio, the DOM Explorer and the console also work against web views, so you don't lose the tools. Like a problem in the past was, say you built an application that had a shell in HTML and JavaScript and then had basically an iframe, a web view as content that you're fetching from the internet, you couldn't debug into that. But now you can. So if you can have any number of web views, and we could be able to support debugging them. And I'll show that later on. So the next also kind of powerful feature of the console is it's a really great way for you to instrument your application. So, firstly, a lot of people obviously just use the console for inspecting objects. Like if, for example, you want to go document.body or whatever, you can see, oops, if only I could type. This is why I copy-paste code, because I'm not very good at it. And if you're familiar with this console, I'm sure many of you are, you have an ability just to inspect. You have IntelliSense, so you can see what values are available. And a nice new feature is really that the IntelliSense also works at breakpoints. Like we used to have a small problem where it didn't, but now it does. So if you have local scope things on the stack, you can see them. But a nice thing about it also is the ability to tell the console or the debugger information. That, like if anyone ever used a console.log or an alert statement? Yeah, everyone must have at some point. So one of the nicest things now is that console.log will log an element, an inspectable object. So if I use this button here, who's ever wondered what this button does, the fast refresh button? So it's a bit of mysterious, but what it does is, like, you're a web developer, right? You just saving work, pressing F5, you save your changes, press F5, save your changes, press F5. The challenge with, if you have a store app, then your challenge is that it's not just a refresh. You have to load a process up, you have to set the right security context, you have to bootstrap a bunch of other code. So every time you press F5, we build, we deploy, in this case to the emulator, it installs, it then launches your process. And all of that can take a fair amount of time, depending on how complicated your app is. So what fast refresh tries to do is tries to copy the file that is changed across to the target directly, and essentially call the same thing as refresh on that page. So the idea here is if you make a very simple HTML, CSS, and JavaScript change, you can get it across to your target very quickly. The downside with that is if you have other components, say you have a managed code or a native component, and say they have static properties and stuff like that, those things will get completely out of sync. Because on the one hand, your page has been loaded twice, but all the rest of your code was initialized once. And so you can imagine the fun sort of scenarios that can cause. So it's something, use with caution, but it can be hilarious when you can't be bothered to close and start. So in this case, as you can see, what it did was it refreshed. And I also now have logged a whole bunch of elements, which, coming to think of it, I should have probably thought about what I was logging before I went ahead and did that. And the nice thing that you might have noticed now is that the console.log command, rather than just taking a string, will log an object. So, we'll allow you to inspect the object, expand properties, and stuff like that. In the past, it just logged a string, which was a bit of a failing. But now you get a full, rich object to inspect, which is pretty handy. And if it happens to be an element, so say I just log document.body, for the sake of argument, press refresh, boop, boop, boop. You can see it's added that a bajillion times. And at various points, the interesting thing, of course, is that the body might not have contained anything at the time as well. So, you can use the console. I'll be very quick about the console since we've got a whole bunch of other stuff to look at, to both inspect and instrument your page. And later on, we're looking at how you can instrument it for a profiling. Which brings us up to the next task. So looking back at my application, what I want to do is I want to now have it so the score is always visible. So if you remember, I had a score along the top, which isn't very useful as you scroll. It's like, I don't know what I'm guessing anymore. So what I want to do is I want to position that so it's always visible. And so I've gone and looked on Stack Overflow and the internet, and I found a cunning solution, or at least what I think is a cunning solution. And so I'm just going to delete the current solution, which is using a grid control, and add the new awesome solution. As soon as I find it in my awesome copy and paste land. So I'm going to absolutely position it in this case, and then every time the user scrolls, I'm going to move it. And so, it's going to work. It's a pretty, simple idea that, hey, every time the viewport changes, we're just going to update the position. So I'm going to go to my default JS code, and in the initialization in the DOM ready event, I am going to add the code to do this. And so what you can see is that I've got a simple, on the jQuery scroll function, I'm going to calculate, let me just hide this. I'm going to calculate where to draw it. I'm going to do some calculation based on the current, how far it's scrolled, the height of the element, and the height of the screen. So let's see what that looks like. And so this is going to look, this is one of the interesting things about phones, and it's going to be pretty obvious pretty quickly, is that this works. Like a classic thing with HTML and JavaScript is, it's positioned at the bottom, but already you can see how poor that looks. It's pretty janky. You can see it's bouncing off the bottom. And I don't think that's because I got my math right. I'm pretty bad at math, but I'm pretty sure that's the right math. It's just because it's not updating in time. So, one of the challenges you'll have building any sort of phone app is you have much less resources. Obviously I've got a Core i7 running here. Granted, the emulator is a Hyper-V image, but it's janky. On this phone, it's going to look pretty terrible. So that's why in Visual Studio, we ship a whole bunch of tools to help you analyze and look at the performance of your applications. So if I jump over to the Analyze menu here, Alt F2, you'll see this thing. I think you might have seen it, that Kevin did the demo in the keynote. This is what we call the hub, for lack of a better term, the Diagnostics hub. And it allows you to select the tools. So we have a bunch of tools you can use to profile your application. Some problems might be memory, some problems might be energy, some problems might be visual. In this case, I'm pretty sure it's not an energy issue, like I'm not using battery power. Well, actually, I don't know how much battery I'm using. It probably is because I'm using more CPU. So I'm pretty sure it's going to be a UI responsiveness issue. One word of note, as a web developer, obviously you're probably used to the responsive being like responsive design. In Visual Studio and Microsoft land, we use responsive to mean how fast something is. So this does cause a bit of confusion, but in this context, it means how fast and the performance of the UI. We're also going to turn on the CPU usage. And the startup project is just fine. So now when we're starting, we're going to have the profiler enabled, and we're just going to run through that same scenario where that text was bouncy, bouncy, bouncy. Bouncy, 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 bouncy. And now we're going to stop. You can see here already the CPU as utilized. You can see here these two graphs. This one at the bottom is obviously tracking CPU. I think I've got enough data. So we stop collection at this point. And so what this is going to do, it's going to take that data from, in this case, the emulator, parse and render it, and build up an object model. In general, I obviously did this demo on the emulator just because that's where it's more convenient. But in reality, you probably want to do it on the device. And all these tools work against the device. So if you connect over a USB tether, you can choose that as your target, and you'll profile on your device, which will give you much more accurate results. In this case, it's so bad I can see it without having to use the device. So let me just make, so along the top here, just to introduce this tool. Who's seen the visual profiling tools before? A few people, not many, so I'll just briefly introduce them. Along the top here is the timeline, essentially. It's where you use one of the places where you can select like ranges of time to look at. Because one of the, of course, problems of a session is you want to find the piece of information that's relevant to you. You don't want to look at a huge amount of data. You need to narrow that data down. And this actually brings up one of the first problems, is that what data, what range are we looking at? What timeline is important to you? And so here you can see that obviously it's in seconds. You can see it starts at 0 and is now at 15. But that's not very useful sometimes. Like sometimes you obviously forget about like, oh, what was happening 15 seconds into this profiling session? I honestly have no clue. I don't even know 15 seconds ago, let alone 15 seconds into a given point of time. So one of the first things that you should do when you start to profile is you can instrument your code. So here I was pretty sure it's related to the scrolling code because the scrolling code was particularly bad and that seemed to be the thing. So what I can do is use a standard API called performance.mark. So this is a new thing. And go mark and say, yay, scrolling. And so what this does in both IE, so if you use IE or any of our tools, it will essentially create a mark and a timeline. So normally, if you're not familiar with the performance object, there's a way in which you can instrument your code and actually have it, like it's a library, it's an API that ships in every version of IE, well, IE 11. Various parts ship in different versions, but you can use it to instrument your code and collect data from customers. That's one of the key advantages of it. You can get data such as the time it took for the network to finish, the time to first render, stuff like that, and then you can post that up to your server. In this case, we're using it to instrument. Unfortunately, I pressed F5, which is going to launch the debugger, which will not help me profile at all. So instead, go back to this tool. Unfortunately, there isn't like an F5 button for the profiler, so it's very easy to get the things mixed up. So this time, when we run our scenario, which hopefully will be just as terrible as it was the last time, what you'll see along the top, once we've got it, is just little user marks once we finish processing. So you can see these little dots here. They should be telling me add movie, and there should be ones for user marks for profiling. Did I not save it? Mark. Oh, that's wrong. I need to add it inside the scrolling function, else it ain't gonna work. Let's try that again. Sorry. So I just added it inside the initialization code, so it's only gonna happen once. So our tools don't help you if you add stuff in the wrong place, by the way. That's a bit unfortunate. So this time, scroll, and hopefully it'll work like magic. And so what we should see is those little triangles appear along the top, and they'll help tell us what was happening at that point in time. So you can already see them. So here you can see we're scrolling. Obviously, you could pass other data. The data has to be serialized to a string, and you have to be able to really view it in a tooltip. But right now, I can view into a particular scroll and see what's going on. So a couple of things we've done that's handy with this is we've got this new UI filter to events, like a context menu. So you can see that one of the ways you can adjust this timeline is by like dragging, which is fun and all, but another easy way to do it is just right-click, filter to event, and then it changes the timeline to just look at what's going on related to that event, which is kind of handy. And so on the timeline, the top timeline is this user marks, where your marks and application marks go. So if the app startup, DOM content loaded, they appear along the top. The next chart is the CPU utilization graph. And this helps you see, firstly, like how much CPU is being used, like up to 100% in some cases, but also help you realize where it's being used. Like one of the interesting challenges for the web platform is that there are just so many different components of it. There's a network stack, there's parsers, there's rendering, there's the JavaScript engine, there's garbage collectors, and all of these happen in different times, different threads, different places. And so sometimes you need very different tools. Like if I have a network problem, looking at a CPU profile is not going to help me because the problem's, it's going to be network bound. I need to look at the server, I need to look at the network stack. So really this top thing here, and let me clear the selection so it's more obvious, tells you where you think you might start look. Here you can see that the JavaScript, the orange color, is actually pretty minimal, but there's a lot of rendering and a lot of styling, which is in the green and purple. And of course, the graph below just tells you the visual throughput. And so the graph below is telling me when we drop frames. So for customers, your customers will experience, it can, depending on a bunch of reasons, look particularly janky when the frame rate drops. And that tends to be where the hotspots you want to go look at. So here you can see quite clearly it's dropped significantly below 30. So let's just go look at that space. And we'll probably see an interesting pattern that I'm sure many of you have already spotted. That what's happening is that we get this great data from the visual profiler. So like here, you can see that we've got this event listener firing. It's on a scroll event. The listener is you. Unfortunately, that's going to be in jQuery. So if I open this up, I'm going to be in somewhere in a minified jQuery, because jQuery was the one that called add event listener. So this links to the person that called add event listener, which in this case is my library wrapper. And now I go back to the write session. And next, you can see a bunch of interesting things. So this isn't meant as a profiler, like it doesn't tell you every single function call, because that's going to be very monotonous for you to look at. It's going to call out specifically DOM calls. So here you can say we've made a call to offset width, offset height, and we've got a couple of calls to get computed style. And then finally, we set a property. And that's probably, almost certainly, that's jQuery's APIs that are trying to calculate the width and the height of the particular elements. And then finally, they're setting the element. So the interesting knock-on effect for that is that we've done something you should try to avoid in general, is that we've asked for a calculation. We've asked for a specific coordinate or location of an element at a time when IE wasn't really ready to give it. Like essentially, you can imagine anytime you set an element's properties or a style location, that doesn't cause necessarily a perf impact. Sure, it dirties the layout, and the next pass, the browser will calculate it, but it only has a calculator when it comes to draw it. Now we've asked it, just in general as scrolling. It's like, hey, tell us it now. So we've caused these extra calculations to happen. And in this case, you can see very specifically what the style calculation is. You can see like on the elements. So we provide very detailed information about where it's coming from. So you can see here like where it says the div, the ID. So you can easily identify like, oh, it really is that spacer thing that I moved that had the score that's causing the problem. And then lastly, you can see that on top of the layout, of course, we cause painting. And that happens, in this case, on the render thread, as in the main UI thread. So, clearly we've got this silly little problem where we're causing a layout, and we want to avoid that. So I'm going to spend a bit more time on the internet, and I've come up with a better solution for the problem. So what I'm going to do is close. In fact, I didn't really need to close it, but go to default.js. And so this is an example of a problem where it's strictly not in my JavaScript. It's not in my, my actual code that's executing. It's really in how my code is interacting with their DOM and stuff like that. So the first thing I'm going to do for this, because Stack Overflow has told me to do it, is I'm going to delete this code. And that's always the best way to make things faster, is to delete things. By far. Like, if you're ever in doubt, there's nothing faster than nothing. And then what we're going to do is we're going to change to use a fixed position, which is what any sane web developer would have done in the first place, maybe. And so this is actually going to enable IE to do the calculation. It's just saying, hey, if I copy the right thing. So now when I scroll, it's going to work fine. Like there's no visual issues. So an example really here was somewhat contrived, but the idea is you will spot issues using the emulator and especially using the device, and you'll need to use a tool like the Visual Profiler or the UI Responsiveness tool to look into those and to figure out. And a lot of the time, those issues won't just be flat out how long it took you to calculate things in JavaScript. They'll be about the interaction with the DOM and the interaction with HTML. So the next, we've got two more sets of demos we're going to look at. Oh, actually, first, let's show the memory tool before I forget. So the next sort of problems that are interesting, that happen very much so on the phone, is memory. So as you can imagine, you've got a website, and everyone knows that websites you don't care, they navigate, poof, memory freed. A bit more of a problem with store apps, a bit more of a problem even more so on the phone. Because on the phone, memory is much more constrained. The operating system will be more aggressive about essentially tombstoning you if you exceed an allocation. And of course, when you go to the background, you're much more likely to get tombstone hibernated in cases of where you're consuming lots of memory. So it becomes much more useful for you as a developer, or much more important, I should say, not necessarily useful, to fix and identify memory issues. And so that's why we have a bunch of tools you can use for the phone, just like you can for the desktop. We've cunningly called them the JavaScript memory tools. And so in this scenario, there's a little use button at the bottom here that will essentially reload the game. So I'm going to take a snapshot. And so what this tool does, you can see there's this running graph along the top here. So this graph is the total private bytes assigned to this process. It covers not just your JavaScript, it covers everything. So obviously this graph peaked when I pressed the heap snapshot button, as we did a bunch of work in the process to get that data out of there. So I wouldn't pay too much attention to that. It does call the GC as well, so it'll free up any other objects you have. And of course, like the other tool, you have these user marks along the top. They also help you delineate what's happening in your session so you can realize what's going on. So now if I take my, let's just press this a few more times so you can see the memory goes up, take another snapshot. So instantly you can see that there's a bunch of memory allocated, and you've got this quick overview, if you're not familiar with the tool already, that tells you, hey, since the last snapshot, we're up 5.5 megs, we're up a number of objects. But the interesting thing as a developer is you have to figure out when these objects are leaking. Like many scenarios, it's okay for you to grow memory. You have to use memory to do things. It's not possible to do it without it. But the hard problem is often when you have things left over, when you have things you no longer want or should no longer be there, and they're taking up memory. And you want those things to be gone. So in this scenario, as you can see, I'm going to run it one more time and do another snapshot. And so in this scenario, I've expected to have a symmetric graph. I've expected the number of objects allocated and the number of objects deallocated to go, balance out at 0, essentially, like plus 1,000, minus 1,000. But that's not what's happening. Each time I'm getting plus a number and not minus a number. So I'm going to look at the diff of the tool, and I'm going to look at this interesting view here. So one of the problems as a developer you'll appreciate is even in this ridiculously small, simple application, I have over 1,100 objects in this diff and over 3,000 objects in total, almost 3,000. So really the tool, you can't possibly go and look through these things. There's thousands and thousands and thousands of them. So what we try to do in the tools is try to reduce the set of them. So if you're familiar, there's this idea of having these objects left over that I kind of talked to you earlier on. And so here you can see in the objects left over scope, which is this scope filter here at the top, there's only 516. So the idea is the tool will reduce the number of objects and things you have to look about, and you ultimately have to rationalize and decide if the object is something that should be there or shouldn't be there. The tool doesn't know. You might have a good reason for keeping an object around. We also try to do that with these little buttons here, these little infograph things that warn you, in this case, that there's objects that are created, DOM nodes, like elements, but they're not in the DOM tree. So they've been created from JavaScript or created from code, and they've been detached from the tree. So they're never going to be rendered. They're floating in, they're referenced from the window object somehow or from some other global, but they're not currently visible. And so that's probably a good place for me to start looking. And already you can see that there's all these div objects. And if I look down at them, you can see that we get a lot of information about them. So in this case, I can see their tag name, their attributes like ID, class, and source and stuff. So I can pretty easily tell like, oh, hey, it's the movie or the rated app. So if I close this view, and just minimize this and look at another view, you can see here, for example, these are the images. And you can see all these images are being kept around. So the nice thing about the tool is it doesn't just take your memory, obviously, like the strings and primitives you have in JavaScript, but it calculates for the memory the images and stuff are holding on to and other resources, which typically will be much more than your strings and all the other fun things. So if I then minimize that, the most important thing about the tool is trying to figure out how to free those things. So as a developer, say I've narrowed down my set of objects right now, like I've got a smaller set, I think it's these elements here. How do I remove them? Like I can't just delete them, that could have some interesting side effects. I need to find all the references to them and remove the references. And so that's what this bottom graph here is about, which allows you to essentially go back and look at the paths to the root. In this case, it's going to be paths to the window object. So you can see I've got a movie al list. And one thing that's very subtle and very important for you to note is that this light out gray stuff, that means it hasn't changed, because we're doing a diff view, we're comparing 2 points in time. The light out color means it hasn't changed. The black color means these things have changed. So here I'm going to use that as a key to go look for my movie al list over my code. So if I go back to the default JS and just search for, in fact, I'm going to take a bit of a step since we're running out of time. And I know I have a function called clear game, which at the end of the day tries to clear up my code. But in this case, it's not clearing up that element. It's not clearing up that array of objects that I conveniently put there. So if I just go movie al list, and clear it, just by doing this, that should empty it out and return to 0. So the idea here is that the tools over in the memory tool have given you enough information to rationalize about which objects were leaking. You, as a developer, will have to go and figure out what to do about that. Like if you need to remove them, you can see what's holding onto them. Like in this case, the example is there's a thing called movie L list, there's a property of game, and that property is also a property of window, which is the global object here. So the next two things I'm going to quickly talk about were two other scenarios in which the tools can be used. So this has all been about store apps. So hopefully now you've got a sense for how the tools work in the store app scenario, but there's two other ways in which the tools can be used. The first way is also in another type of store app. So if you've ever built a C#, like a managed or a native application, and you used a web view control, like I'm sure many of you are familiar with this control, it's basically the web browser embedded. It's been around in various forms and shapes since like WinForms and stuff. And so the great thing of the store apps, we also support debugging of these. So if ever you have to put HTML and JavaScript into a web view, what you can do, and this is completely changed context, you can go Properties. So this is in a C# application I've created. It has two web view controls. It's just a vanilla C# application for phone. It's nothing special. And you'll notice that in the project properties page, there's this debug option, and underneath it has a debug type for the application. So in here, I can choose script. And now when I launch, and this is using the 512 meg version of the emulator for no particular reason, you'll see that there's these two pages. So you see how actually this looks quite a bit different than the store app, because this is just using a regular web view, which has applied the text scaling, which is why the score size is so big, and has also applied, it's not applied the same sort of zoom thing. But the nice thing is, if I go to debug Windows, I can see all the DOM explorers. So we don't show them automatically, it's based on a couple of settings, but here you can see that there's two web views, like I mentioned, one for this and one for that one. There are two separate top-level tabs, just because there's no like direct parent to them in a tree. So here we can go and inspect this one, and we can go ahead and add a property like font size and change it, just like you would. So all the tools work just as saying profiling also works, and everything else just as you expect. Oops, two me's won't help. Two ems. And of course, you also have the console, since I find it, which is at the top here. The thing about the console is that you use this drop down on the top right to change your target. So if I go to here and type document.title, you can see this should be in the build advert. And then if I go up to here and select it, it's going to be in the other app. So you can switch between, like, because you can only use the console against one thing. We have to evaluate the code somewhere. So that's how you select where to do it. And like I said, it works against web views. This target thing also works against iframes, which I've not used in this demo, but it works fine against iframes as well. The last and probably more exciting place you can use these tools is if you use normal IE. So if I just go back here. So there's two features we added to support IE debugging. So say you're creating an ASP.NET application. You can select in the drop-down for ASP.NET, you can select to target Windows Phone if you have a version of Visual Studio that has all the phone emulator and stuff like that. So you can launch your ASP.NET application against the phone. You can have your localhost server running on your dev box, and you can have your device connect to it. You can also, if you're not using ASP.NET or you just want to attach to a website in IE, there's also this new option in the debug option called Other Debug Targets. And here you can see, this is where you can choose like to attach to applications you don't have source code for. So here we're going to choose the Windows Phone. And again, you get the choice of emulators or the device. These things all work into the device. Here you type in your URL. And it can be anything. It can be any URL. Here, localhost doesn't refer to the phone. It refers to my desktop, or my laptop, really, that's running this site. So now when I launch, we'll hopefully see IE launch. It'll probably prompt me to use the recommended settings. Oh, I got the wrong. This is one of the challenges when you have too many windows open. Not that one. Nope, not that one. It's this one. And so like here you can see the same tools again, DOM Explorer, console, and again the profiling tools all work. So the way you use the profiling tools is you stop and you use the Analyze menu, just like you would for profiling your own startup project. And in here you can see, if that was too quick, and that was, you can see in the Change Target, there is a option to choose Internet Explorer for the phone. So if you ever have a mobile website and you're having problems with it perf-wise, like it's visually or something like that, you can use the same tools that you would for the store apps and those different targets. So like I mentioned, you can use this for both for ASP.NET, where it'll appear in the drop-down, as well as just debugging any old site, regardless of what it's from. Just so long as the emulator can find the website, you should be able to debug it, which is pretty handy. So concludes most of the demo portion. So I'm just going to flip back to the slides and hopefully have a few minutes for Q&A. Skip. Yeah, so we did those demos. So yeah, so just to wrap up what we've talked about. So essentially in this update 2 of Visual Studio, all the tools that you would have used or have seen used for applications using Windows Store, JavaScript applications, or IE in Visual Studio are available for phone. And when that includes IE, that includes the store apps. You get the diagnostic tools, the debugger, the profiler. They work in all the contexts we talked about, phone, IE, and of course embedded in phone store apps. It's only 8.1, so the two drawbacks here, it doesn't work for Silverlight 8.0 and Silverlight 8.1 apps, but it does just work for the regular store apps, but not the other ones. So in general, like hopefully you'll learn a few things about the tools. Like at least now you'll have a place to go when you need a problem, or you have a problem. You don't need a problem. No one ever needs problems. We just have them. So hopefully learn a couple of things about the tools. We've got a few more minutes for Q&A, sorry, not Q&A. So I think we've got a total of like 9 minutes almost. So does anyone have any questions? Nothing at all? Oh. All right, well, I'll be hanging around after if anyone has questions. Don't forget, at the end of the day, 2 other things. I've got a session on F12, so if you are a web developer, there's a session on Friday where I'll just be talking about the updates we made to F12. So since IE11 has shipped, obviously a while back now, we've obviously got the update now to 8.1 and updates to IE11, so we added a bunch of features in the F12 tools, such as like just my code and source maps, which we'll be demoing. And then also after this talk tomorrow, I'll be on the booth between 11:30 and 3 p.m. So feel free to stop by. It's the Visual Studio booth. I think it's on the 3rd floor. Feel free to stop by, ask any questions, anything relates to like JavaScript, web client stuff, and I'm more than happy to help, obviously. Oh, and then the last slide. Don't forget your feedback is important. So yeah, so I'll hang around here if anyone has any questions. Otherwise, I think that pretty much concludes my talk. Thank you.